Good morning, friends. Today we will cover chapter 16, how inheritance affects serialization. Okay, so if a superclass is serializable, which means that the superclass is already implementing serializable interface. So all the subclasses would be we don't need to mark all the subclasses as serializable because all the subclasses will already pass the is a relationship with the parent class, and because the parent class is already serializable, all the subclasses are automatically serializable. Now suppose that if a class does not, there's a standalone Java Pujo class, and it does not extends any other class. It's not a subclass of any other parent class, and it also doesn't implement serializable. In that case, we can always ensure that that particular standalone Pojo class is not serializable because we know that all the classes, the super parent of all the classes is always the object class, right? Object which is defined java.lang.object. So all the classes are subclasses of this java.lang.object class, and this object class does not implement serializable. Now suppose what happens that suppose we have got a subclass which implements serializable, but the superclass does not. So how is this going to affect serialization? So this is what we will discuss in this chapter. So far we have been learning that once we deserialize using object input stream dot read object, it always creates the copy of the original object. It's not exactly the same object which was serialized using object output stream dot write object. It's not the same. It's a copy of the original object. Now we all always know that other way that the normal way to create any object is using the new operator and the class name, and then we call the constructor of that. So let's see what are the various phases when we use the new operator and how is the whole object being created. So first of all, first step is that all instance variables which we have defined in that class are assigned default values. For example, the int is defaulted as 0, double as 0d, a boolean as false, and string as null, etc. So if we look at this particular example, so in this Java Pojo class, we have, once we create a new operator, new market data with inheritance, for example, this Java Pojo class. So all these fields, right? So we have got string field. So it will be, first of all, the first step is that security ID would be given a null value. Similarly, long time would be given a 0L, and all the double fields as 0D and boolean as false. And this reference object would be marked as null. Now, after the first step, when all the instance variables are assigned default values, the second step is the constructor is invoked. The constructor can be without any parameter or with parameters. So if we are using a this operator as inside the constructor, then it will call some other constructor, but eventually it will call the superclass constructor, because implicitly a super is called as the first line of the constructor if there is no this operator. So what I mean is that here in this, suppose I call this new market data inheritance without any passing any constructor and constructor parameters. So here inside this, there is an implicit super being called, or otherwise, in other words, we can say that super. So this is implicitly called if we don't call it, unless we have got another constructor with market data with inheritance. For example, if I have got say alt insert market data with constructor, and I choose some of the fields here, then it will and call a this operator here instead of this. So it will call that this operator. Okay, but as we in this class we don't have any other overloaded constructor, we only have a default constructor, which means that without any fields, then implicitly it will call super, and this super is actually calling the parent class, which is identifiable. So it will call, if I just do this, it will call this constructor. Here in this is a parent class, and we have seen that it's not implementing serializable, and we have got two constructors here. One is overloaded with this ID field. We can assign it, or otherwise the default constructor is also there. So from market data within the second step is this constructor is called, and immediately the implicit super is called, which will call the identifiable, this constructor. Now the third step is that after calling the super, all superclass constructors complete. So if we have got any initialization there, for example, here if I have, for example, if we have called this one, or from here I called this ID something, then it will be completing this constructor and giving these values. ID would be given a value as we have assigned in the constructor. So once this is done, the fourth step is that after the superclass constructor is complete, then instance variables are initialized as part of their declaration, are assigned their initial value, overriding the default values. The default values means from the step one, whatever we had defaulted as 0 or null or whatever, they are changed and they are given the values which are given in the constructor. So what it means is, in the after we have completed the superclass, and suppose we have got some other initialization of fields, like we are setting security ID as some value or time as some value. So all this would be assigned here at this step. For example, say if I assign security ID as, say, Meta, Facebook's. So then this security ID initially it was defined as null in the first step. In the last step, it would be overriding this value of null with the actual value that we have assigned. Ideally, we always have the overloaded constructors assigning some very important fields which we want at the initialization of the object. So this is what all the steps are happening. And finally, when the constructor completes, we have got the object created in the heap, and with all those private field members assigned the values as given in the constructors and the superclass constructor. So these are all the 5 steps which happens when we use the new operator. But these things do not happen when an object is deserialized, right? Now just think about it. If during the deserialization process we call the constructor same as the new operator, then the whole purpose of serialization and deserialization has no meaning. If the constructors were invoked and our variables were assigned the values given in their declarations, the object we are trying to restore would revert to its original state, rather than coming back reflecting the changes in its states that happened sometimes after it was created. So we are doing serialization when we have got an object in a particular state, and we want the same state to happen once we deserialize it. If we call the new one, if we call them as the same as new operator when we are calling the constructors, we are calling all these 5 steps above, then it will be restored to its original value and it will lose its values, whatever the state it was before serialization. This is what we don't want during the deserialization process. We want exactly the same state as it was there before just before the serialization. So this is what. So what happens that if the superclass is not serializable, the instance variables in the subclass, the instance variables which implement serializable, will be serialized and deserialized correctly. Without calling any constructor or anything. But the inherited values, guys, this is a very important part. Only the inherited variables from the non-serializable superclass will come back with their default initially assigned values rather than the values they had at the time of serialization. So what it means is, market data with inheritance. This is a subclass of identifiable parent class. So once we serialize this object, all these fields which are mentioned here, that would be serialized because it's not transient, and also we are not using whitelisting. So in that case, all these fields mentioned here would be serializable and deserializable, meaning that once we deserialize it back, it will not reassign it to its original value. It will not call this constructor and mark security ID as Meta. If security ID was like changed to Apple or some other or any other security ID, only that will come back, not Meta, because constructors are not being called. But there's one field which is inherited from identifiable parent class, which is ID. And this class, as we have discussed, that this class is not implementing serializable. It means that for ID, because this is the only field which is inherited to the subclass, and here it will come back as the original value of null. It will not come with whatever the state. Suppose we have changed the state here and we change that ID field uh, in the state in the subclass state as say whatever 5L or 6L or whatever 567 whatever number it is, and once we deserialize it back, it will come back as null because that ID field is inherited and the parent class is not implementing serializable. So it will call the basic 5 steps that it will call the superclass constructor, and then it will assign the null value to ID. And while deserialization, it will come back as null, not with the value which was there before the serialization. So just to summarize here, if a subclass implements serializable, but the superclass does not, then any instance variables inherited from that superclass will be reset to the values they were given during the original construction of the object, means calling the superclass constructor. This is because the non-serializable class constructor will run. This is the most important point that we have to learn in this chapter. And in fact, every constructor above the first non-serializable class constructor will also run in the inheritance tree. For example, if in this scenario, if identifiable was again extending to another class and it was again extending to another superclass, all the constructors, the chain like super would be called for each of them, and each of the fields which were inherited in the subclasses, that all would be initialized to the default values or to the constructor assigned values. So this is what we are going to learn in this chapter. So enough of the theory now. In the next video, we will dive into the IntelliJ and write some code to understand this better. So see you all in the next video.